Hey, what's up guys? My name is Cherno and welcome to the 12th episode of the Serialization series. So, I know I said last time that we would be talking about reading files, right, and deserializing stuff today, but I just realized just now that we're actually missing one piece of the puzzle as far as our serialization goes, and that is strings, right? We cannot serialize strings right now. I mean, sure, I guess we could convert them to bytes and serialize that or something, and we've got the ability to serialize all these primitive types like integer, short, all that stuff, and they're called fields, right? We also have arrays, which we can serialize, right? And then all of that kind of goes into an object, and then that goes into the database. But we can't, like, what if we want a field that is a string? How is that going to work, right? Well, glad you asked, because that's what this video is going to be all about. Now, the way that we're actually going to implement this is as an array, okay? There's two ways you could go about this. You could implement strings as a field, in which case you would have to, because you would have that. You would have a name length, you'd have a name, you'd have a type. In this case, you would have to set the type to string, which is something that you basically, like, we don't really want to do that. Because if we go into the types here, you can see that really these are all primitive types, and they're kind of supposed to be primitive types because they're primitive in the sense that if we look at get size, we know the size of the type all the time, right? If I had to add a string here, what would the size of the string be? Well, that kind of depends on the amount of characters in the string, right? It depends on the actual string. A string is going to have a string is going to have a different size depending on what the string is. And you know what else has different sizes depending on how big they are? Arrays, right? Which is why arrays kind of make more sense. You might want to refer to a field, to a string as a field. Because when you think about it, a string is like one little object, right? A string isn't something that you can... it's not like a range. It's not like, it's not really like when you get it back, you're not expecting to get an array of characters back or anything. You're expecting to get a single object, a string. So in that case, it kind of is like a field, but of course the actual kind of low level implementation of a string is just an array of characters, which is why it works so well for this. So we're going to kind of go through this and decide how it's going to work. So first of all, the container type will be set to array. Okay, the name will be fine. We'll have a name. We'll have a size, of course. We'll have a type. Now the type, this is where this comes into. This is where stuff kind of starts getting real. We could store the type as a primitive type, being one of these, or we could actually set the type to string. Again, if we did set the type to string, then it wouldn't really be. This is really supposed to be the primitive type. Yeah. When you think about it. And you're thinking about when you're actually thinking about serialization in general, right? You can only serialize primitive types. That is as far as serialization goes. Yeah? You have to write out primitive types. That is how this works. Okay? If you don't, for whatever reason, or if, well, I don't know what will happen, right, you can't actually, there's no way to serialize out a string, because what is a string, right? A string is a collection of primitives. A string is a collection of characters, right, of chars. So, that being said, we can't really serialize out the string. We have to serialize out a char array. Now, however, the problem comes from reading, not writing. If we wanted to write this out, we could easily do that. In fact, even in the current system, if I define a string, and I wanted to serialize that for some reason, and I won't do it here, but let's just say I do call something like object add array. You can see if I type in like hello world or something here, there is a way to get the chars back, and really a char sequence, like how do I get... I don't know, man. I don't really spend too much time with Java nowadays, so I don't even know how you, surely there's a way to get the char array, of course. So there we go, right? We just do that, add array. Of course, this has to be a new, or rather an rc array.char string name string, for example, and then the data being, you know, that. And then there you have it, right? We've serialized out a string, haven't we? The issue comes from reading, right? When we actually decide, okay, hey, now I'm going to read in my string. How do we know if this is supposed to be a string or if it actually just is an array of characters? Like, should the data be interpreted as an actual string, being like, you know, capital S string, right? Or should I interpret the data as a char array? That's kind of where you have to start thinking about it, right? Again, we could even make something called RC string, and then objects contain fields, arrays, and strings, okay? And that's actually a plausible solution. I'm actually considering doing that right now. We probably will do that, because the thing is, if we did carry this as an array, we would be forced to do something in this array to let us know that, hey, actually, this is not really an array, it's more of a string, right? And if we have to do that, then, you know, we start getting into kind of, you know, do we have an extra byte here that says is string, right? Or do we maybe change the type to be a string, and that kind of starts interfering with what an array actually is, because an array should be an array of primitives. And again, if you did want your string to literally be a char array, and specifically you wanted to have it as an RC array, then, you know, you can do it this way, like I just said, right? And that will work totally fine. Like if I launch that right now, obviously it's not going to crash or anything. And if I quickly open up the file here, you know, you'll see that hello world written over here. Now, one thing I'll note is that obviously chars are obviously 16-bit, right? They're 2 bytes in Java, right? Which is why you have this kind of extra byte here. That's important though. You usually, like, they're basically called wide strings, or rather wide characters, because in order to support more languages, and of course, you know, all these different symbols that certain characters carry, we need more than 250 possible characters, which is why a lot of these, that's basically the reason that this isn't, that these aren't single bytes, right? They have to be 2 bytes if you really want to support everything. So you kind of get this, but you still get the idea, right? This string gets serialized out like that, and everyone is happy. That's why char is 2 bytes and not 1 byte. Anyway, that being said, that's how that works. And you can see it does work. So really though, if we do want strings, we're gonna have to create RC string. For the most part, I'm actually probably just gonna steal this entire class, just because I don't need everything. Let's get real here. We don't need get data size. Let's just take everything up to here. I'll start deleting stuff. I still think it'll be faster. Container type, string. So we're changing this format a little bit now, because I'm gonna say array field string is 3, object is 4, database is 5. So this is potentially like a format breaking change here. Luckily we haven't like released this format or anything, it's all good. So container type will be string. We'll have a name, of course, same as always. We'll have a size, which we'll have to address later. We'll have a type. No, we won't. We won't have a count either. We're really just going to have a bunch of char data. All right. We do need the size there, of course, to let us know how many characters are in there. This size will actually be a count, though. Now, this assumes that chars, again, are 2 bytes. Okay? That's the way that this cookie is going to crumble. Okay? We can't suddenly be like, oh, actually, I'm going to deal with 1 byte chars. No. We have 2 byte chars, that's it. And especially because this is written in Java and char is always 2 bytes, we should be pretty safe. We'll make the constructor private. I mean, we probably don't need to. We could instantiate it by just using new string, I guess. But anyway, we probably will have size, actually. We are kind of having size from everything, right? Because size isn't the, we'll have size and then we'll have count, right? I think that's what we did for arrays as well. We had count, okay, we had size type count, sure. We definitely need to have that as well. We'll set up size later as well. Update size, yeah, I mean, we could probably say that, how do we rock that? I think we just, when we created it, we did something along the lines of update size, right? That's how we did it. So let's steal maybe the char one, because that's the most appropriate. And we'll just place that here. Get data size again. Don't really care about that. If we really wanted to implement that, I mean, it would literally just be that. So char data, I will rename to just data. Or I might call this like characters. So as I was saying, if we wanted to, let's also kind of remove all of this. If we wanted to return that, it could literally just be characters.length times the size of the char. Get size, that's the kind of the data size. Get size again returns size. Update size would be that, sure. So that's once we set it, we can kind of update it. And then as far as this goes, this needs to return an RC string. So what would it be? RC string dot new or something. I don't know. Like, I guess you could call that. Again, as I said, this could just very well be a constructor. I guess I'll call this create, but this could be done in the constructor in this case. No reason it's not really. So we'll create a new string. We'll have a name, and then we'll have the string data, I guess. Okay. I'll call this string. So let's see what we actually need to do. So string.count will be the amount of characters. I could probably, yeah, okay. So let's do this. This will be data.length. String.characters will be data.toCharArray. And then we'll call update size, and then we'll return string. And that looks pretty good to me. We obviously need to set some other things here. So for example, I think, oh, we did set name, right? Yeah, so we need to do set name to name. Count gets set to data length, good. Characters, again, we update size, sure. So at this point, we need to know the size. So the size should be, again, the final byte container type, 1 plus 2 for the name length, right? Plus whatever the name is. So we work that out here. And then plus the count, which is an integer, so it's 4. I mean, again, do we really need that to be an integer? Probably not. We could though. The size field itself needs to be included. So that's what it is. Yeah, 4 billion characters, or sorry, 2 billion characters should probably be enough. Yeah, I mean, I'm gonna just say that's enough. We could make this a short if you wanted to. Again, something that you should decide for yourself. I'm gonna leave it as an int so that we're pretty happy with all of this. Okay, cool. So this is looking pretty good to me. I'm just checking. Yeah, I'm pretty happy with that. All right, cool. So there we have it. This should be good. Yes. Okay, cool. So if we write the bytes out now, we write out name length and name, and then size and count is what we want to do. So we've got count, we don't have size. And then we actually write out the characters, which of course is just going to be characters. Okay, cool. So that does exist for that. Cool. Yeah, I mean, that is it. So in RC object now, I need to store a bunch of strings. So we got field count. We'll have string count because I do want to kind of still treat fields like strings in a way. RC strings. We'll call it strings. When we serialize this stuff out, we will write out, we'll copy this block here. We'll write out the string count. RC strings. String.getBytes, destination pointer. Okay, cool. There we go. So that should work pretty well. So now, instead of having to add hello world, we'll do that anyway, actually. Maybe after though, we'll say object, doesn't matter of course the order here. But anyway, we'll say, okay, we need the add string thing as well. So let's find add field, add string, rc string, field, so this will be strings.add string size plus equals strings.get size, string.get size, and then finally the string count of course will get changed to be strings.size. All right, brilliant. So back here, we'll add a string. We'll say new, or we can't do that, so we'll do rc string.create example string data testing our rc string class. Okay, cool. So we've still got the hello world there, but we've also got this. So if we run this now, and we take a look at, I obviously closed it because I do that all the time. Let's quickly take a look at that. Then what you should see is, of course, as I mentioned, if we look at the structure of RC object, strings get serialized out before arrays, right in the middle of fields. So we should see our fields, X position, Y position, then we should see our example string with the testing our RC string class, which is what we see here. Again, 2-byte characters. And then we see those arrays, okay? And if we look at the string count, which we should see right before the amount of strings, so once the fields are finished, so literally before string, it's actually a little bit difficult to see this. It's almost better to just have it all at the top, but we don't. It's okay. There are advantages to both systems. This plus is that Y position, right? So then we have, what do we have? So that's the end of the Y position is that, I believe. No, it's not. Yeah, it is. Okay. So then we have 0 and 1, which should be our string count, right? And then we have, I guess, the type, which is string, which is 3. Okay. And then we have inside of the RC string class, we're here now, we have the name length, which is a short, which is, no, we don't have that apparently. Hang on, container type string. Oh, that's that. Yeah, sorry, I thought it was 2 bytes, but it's 1 byte. So then we have the length of name, which is E, right, which is 14. And then we've got our example string, which is our name. And that is 14 characters. Then we've got the size, which is an integer. And then we've got the count, which is also an integer, which is why it says here 1b, right? And then we have the beginning of our thing, which ends here, or rather here. Okay, straight after that, oh, sorry, string class ends here, okay? Then we have, I guess we go back to, yeah, there's that short. So we go back to RC object and we have our array count, which is this next short, which is 1 array. That's the container type, that's the length of the name, that's the name, that is, I always forget this, the size probably, no, it's not, can't be the size. What is it, count or something? No, it is the size, 3, really? Do we, hang on, where do we size out? Oh, we don't write the size, all right, that's the problem. We should write the size. I guess we should probably write the size before we write anything else as well. We'll deal with that later. So yeah, so we should write the size, but we don't. So count is 3, which is a hang on. No, type, sorry, is 3. Then we have an integer which says what the count is. And then we have our hello world. All right, cool. So there we go. So arrays and strings are now working. Yeah, size is something that I feel should get serialized out as pretty much the first thing. So you have your container type, and then you probably should have your size straight away. So that if you want to, again, skip ahead, you don't have to go through the name length and the name to get to size. So that could be something. But anyway, right now we'll still keep it like this. And I guess right before the type is when it should get serialized out. So size. Did we actually write that out? I guess we write that out for everything, don't we? RC field, for example. We write out the size for that, surely, yeah? No, we don't. Maybe I'm not supposed to write out the size. RC field doesn't have a size. Okay, because the type has a size, yeah. RC field, we don't need to do that. Array, though, I would. And then finally, yeah, for string, we are doing that. There's the size. All right, cool. So that is it. You can see, I was about to say, as you can see, it runs, but clearly I added the size without actually adding it. So let's go back to RC array. So we have the count, which is there. So let's just make sure we just go 4+ so that we have that. So if we now run it, we should be all successful and everything should work as expected. All right, guys, thanks for watching another episode of Serialization. Next week, or next episode, it's probably not going to be a week from now, but next episode, we're going to go on to deserialization, okay? So how we can read this data that's in our file format back into our kind of runtime memory. All right, thanks for watching. If you enjoyed the video, please hit the like button, and I'll see you guys next time. Goodbye.